Hello guys, we are talking in this video about the deformation produced in solids with the application of the forces. You can see some examples on the screen. Some deformation that is produced is temporary. For example, this one, when you press the balloon, it actually deforms, but later it comes back to its original shape. What about the can? When you press it, actually it deforms, but when you release the force, it doesn't come back. So we will study about how much deformation is produced with the application of a force into something, and when it's a permanent deformation and when it's the temporary deformation. Let's take an example of a spring whose has a original length. For example, the L0 is the original length, and we have put a load on it. So when we put a load on it, it deforms and it extends actually, and its length become L1. The extension produced due to this load, so load applied, is equal to the mass in kilogram multiplied with g. So unless you have mass in kilogram, you cannot actually write the load in Newton. And the extension produced is this one, which we can say delta x, and delta x is the current length minus the original length without the load. If we put more weight on it, it is extended more and more and more. So we keep on adding the masses, that increases the load, and the extension is increased. So now let us unload this given spring. It tries to come back, okay, then it's unloaded. Now if we see the length, it's equal to actually the original length which was before the loading. It means whatever the deformation has been produced over here is actually restored. So when you apply a force on an object, it deforms, but when you unload it and you remove the force, it restores its shape. Then this kind of deformation is called as elastic deformation. The deformation which can be restored after the removal of the forces, this is called the elastic deformation. Let us take an example where the extension has been produced in a spring, and the increasing load produces the extension. The load, as I said, the mass in kilogram multiplied with 9.81. Let us take some data. So you can see the extension produced with every load is actually calculated by subtracting the current length and the unloaded length. So we get a data between the load and the extension. So we are increasing load that produces the extension, and this data, if we plot on a graph with load and extension, so we may get a straight line. It means the load and extension are directly proportional. So as long as you get the load and extension graph straight line, it means the load and extension are directly proportional. This is only possible when you have the deformation which is temporary. So actually when you unload this, it will restore its shape. So the graph here shows the proportionality, and this could be described with a law called as Hooke's law. The extension is directly proportional to the load under the elastic limit. So what is this elastic limit? This elastic limit is the maximum value of the force that can be applied without producing a permanent change. It means when you cross the elastic limit, the material is permanently deformed. It means we can still use the material under the elastic limit if we don't let the materials to deform permanently. And this is important in many applications, that, for example, you are using a key to open a door and you apply a force, a certain deformation is produced. If this deformation is produced permanently, then you cannot actually use the key again. So the key must be made by a material that must not be deformed permanently when you open the door with that key by applying a sufficient force.